Assalamualaikum and good day. So let's continue our soil classification for sieve analysis. So just now we already discussed and see the video on how sieve analysis is conducted. So actually the test is for dry sieve analysis, and the aims of the test is we want to define the percent of finer or percent of passing soil, which is 100 minus cumulative percent of retain. So in sieve, if you see the sieve number and also the stacking of the sieve, so at one particular sieve, soil can retain, retain and can be passed. Soil can retain and can pass through an opening. So let's say you have a sieve. So if you pour the soil into it and shaking it, so the soil can be retained if the size is larger than the sieve size, and the soil can be passing. So the one that we would like to know is how much the soil passing the sieve, each sieve. So in here we can see 80%, 81.3% passing the sieve size now with the opening of 4.75 millimeter, and 70%, 72.6% passing the 2.36 millimeter of the size. And until the rest, we know that still at the last size of the sieve, the 200 sieve of 0.075 millimeter sieve, we have 3.2% passing it, and it lays at the pen about 24 grams. So if we could understand the system of calculation, so we can understand actually how much the soil it is for each sieve. So what we would like to we also can learn from the sieve is, let's say here for number 200, so the passing rate of number 200, let's say this is a barrier of 200, so it is 3%, 3.2%. So only 3.2% is a finer soil. Finer soil. It could be clay, it could be silt. So to know either it is clay or silt, we can do another test, which is Atterberg limit test. Okay. So anything that retain on the number 200 is the sand. All of this is sand. Why I'm saying this is sand? Because we are using the biggest one is only the sieve number 4. The barrier between the gravel and also the sand. So I could say that only less than 20% is a gravel. So sand is here until here. So on only 72.6 minus 3.2%, it will be 69% only sand, and 100 minus 81.3 is gravel. So if we could total up, it will be about 20% in here, 70% in here, and about less than 5% is here. So total will be 100% again. So that's how we check the sieve analysis. Okay, next, from these results, we can plot the from this result we can plot the passing percentage, passing percent versus the particle sizes of the sieve opening, So if we want to check again, okay, why I'm labeling is from 0.01 until 100 is because it is a log graph, so it is raised in the 10 power, in the power of 10. And from here we also can learn the sieve opening ranging from 0.075 up to 4.75, so less than 10 mm. So that's why um, in the graph we start to plot, we want to have a 0.075 around here until here. Okay. So later the curve like maybe around in this region. And for the passing percentage, of course, you can start from 0 up to 100 and it capping at 100. So putting all the values, okay, for the 3.2% it is for 3.2% at the 0.075 millimeter. And next for the number next is 8.7% and so on until 81.3% for number 4C with the opening of 4.75. So let's see. So we have 8 points and also we can plot a curve. So please note that the curve is curvy, not a straight line, and you can draw the best fitted if you have two obvious different point in here. So best fitted curve to plot the graph. Okay, what we do from these results is we can identify the effective size of D10, D60, D30, and later we can identify the uniformity coefficient of C sub U and also coefficient of gradation. Sometimes is wrote as C sub C, sometimes also wrote as C sub G gradation. Okay, so from the results that we have just now, so this is the D10. We just define what is the effective size of 10% passing, so we can get the results. We also do for D30 and D60 because we want to use in the CC and CU coefficient. So if CU is bigger than 5%, so the soil is considered as well graded, whereas for less is uniformly graded. For the CC, I think this one, CC is well graded, and if defined between 0.5 to 2, and it is possible gap credit if it is less than 0.1. So how the well graded look like and how the possible gap credit looks like. So actually, if we have like C is a gap graded, so you have some of the soil in the cobblers but very small percent in the gravel, and you have some more in the sand. So you have a sand gap, doesn't have much in the gravel, but you have a cobblers, so it's a gap graded cobblers sand. So if you have like a B, so it is well graded. Why? Because a lot of the results touching in the wide range of the gravel and also sand and also silt. So a well graded gravel sand. I think B is well graded gravel sand with a slightly silt in it. How about poorly graded? So poorly graded is like A, which is only have one type of the soil sizes range, only have a sand in it. So it's a poorly graded because in sand for the construction, for engineering purpose, it is much more accepted if we have a wide range of soil, the well graded soil, compared to poorly graded. Because poorly graded may easily lead the soil to fail because of the similar size of it. It's not fill up the voids and so on. So that's why we are prone searching for the well graded soil. Much more better for the construction. So I give you example 2 and the answers. You can also try to do this example, and the next example 3. Try to define what is how much percentage of the gravel, sand, and also the clay. Okay. Okay, for the attribute limit, we have a similar condition for USCS, BS. Note in mind that the barrier between the finer and the coarser grain soil for US and BS is different. Okay? But still, the attribute limits we also have in the USCS and we also have in BS. So, what is attribute limit all about? So, actually, it is related to the water content in the state of the soil, especially the finer grain soil, the clayey soil. So let's say, okay, here. So in the volume of soil, when we have a moisture, if the moisture is quite high, so the soil is not knowing to have a liquid limit. When it reduces, so it can have a state of a plastic soil, and at the state of plastic to go to the brittle is become a plastic limit definition define. We can define the plastic limit. And once the soil is easily brittle, so they might have a shrinkage limit as well. However, in our course, we only cover for liquid limit and also the plastic limit test. And the liquid limit test is known as a cone penetrometer, while for plastic limit is a roll track. So the liquid limit is a stage of it is a state of soil which is looks like a pea soap. So when in the plastic, so the soil looks like a peanut butter and change to cheese in the semi-solid, and can have like a hard candy for a solid soil. It almost reach the state of rock. So that's why the soil looks like a hard candy. So what is cone penetrometer? The minimum moisture content at what is liquid limit? That we later do with the cone penetrometer test. So it is a minimum moisture content at which the soil will flow under its own weight. Whereas for the plastic limit is the minimum moisture content which soil can be rolled without breaking up in the size of 3 millimeter in diameter before it jumps into the shrinkage or the semi-solid state. So what is shrinkage? So shrinkage is the limit that the maximum moisture content which further loss of the moisture will not cause a decrease in volume of the soil. So from the liquid limit and plastic limit, we can identify the plasticity index, or shortened as PI. Note that the PI is liquid limit, the bigger value of the moisture minus the lower value of the moisture, plastic limit. Okay. So for the track test, you can go to this YouTube and watch. But the procedure is in general is like this. We have a soil that shaped into a ball, and we divide the soil into 4 equal parts and turn the soil into a track with a 6 millimeter in the size, the diameter. And by using a steady pressure, try to make it smaller, 5 to 10 times back and forth movement. And when it's crumbled at the 3 millimeter track, so it is a plastic limit. If it is crumbled earlier than that, so it is wrong, so we have to restart the test. Okay, I think I stop here. In next video, we will see how the cone penetrometer cone penetration test is conducted. So I think that's all. See you again. Assalamualaikum warahmatullahi wabarakatuh.